I don't know. I don't like the new Zoom. It's kind of weird. Okay. So this is today's agenda. We're going to go over some basic programming in Python. Then we're going to go over some LEET code using Python. And after that, we're going to go over some basic quant connect algorithms. Okay, so let's just close that. Okay, so let's go over. So this is Python. This is a Jupyter notebook hosted on Google Colab. It's a free way you can just use Python without like installing a bunch of stuff. I personally like to use it because if I don't have Python installed on a computer, or if I just don't want to boot up my Python IDE or anything, I just pull this up. Okay, so what is a variable? A variable is just a way to store data. It's just something you can store data. So like in math, you have like X, Y, and stuff like that. So like we can have X equal 5. And in math, you know this 5 as like an integer. But if we added something like a 0.5, then it become a floating point number. So it's pretty analogous to math. And how do you store something like words or something? So we say like, so let's just create a variable called greeting. So hello, how are you doing? And so with strings, you can store all kinds of words, numbers. You can store just like a bunch of like stuff that might not be able, that you can't represent in an integer or like a number. Like you can't represent hello, how are you doing using a number. And a Boolean is like a true or false. So sorry, one second, my mom's calling. 怎么了？是我，怎么了？Sorry about that. Okay, so Boolean is basically true or false. So like you can have a Boolean like has 4 legs and it'd be true or false, right? So if you're a human, it'd be false. But if you're like a dog, it'd be true. Okay, hopefully that's okay. So it's not too, hopefully it's not too complicated so far. Okay, so let's go for what operations are. So so this addition and subtraction, 5 plus 10. And you can even, so let's say we even have a y. Okay, so we can even have like another variable that contains some number or something. And then we can even print out like, what's the x plus y, add variables. And we can add numbers. We can add, I mean, subtraction is basically the same thing. Do subtraction. It's how you do multiplication. It's just the shift 8, the star symbol. Okay. It's pretty simple so far. Hopefully that nothing's too complicated. Okay, so now something that might be a little confusing in Python is division. If you guys are familiar with languages like Java or C++ or something, typically division just like between 2 integers results in another integer. So say like, let's say we have like some random like int x equals 5 divided by 2. So what would this x be? If anyone wants to type in the chat or answer. This is pretty simple. Let me just get some engagement. Does anyone know the answer? 5 divided by 2 in Java or C++? Yes, that's correct. Parker, yeah, and William. Okay, you guys got it correct. That is because like it goes to 5 by base 2 is 2.5, but in Java the integers are truncated, so you just get rid of that decimal. But okay, so does anyone know what this is in Python? If feel free to type in the chat if you guys know the answer. Yeah, that's correct. So you can see here division into between two integers in Python does not result in another integer, which might get some people. So this is just something to look out for. So how can we get the typical object-oriented or like other non-Python division to make two integers divide? What we can do is do something called floor division. And so what floor division is just, it takes the result of the division and then just goes to the floor, or basically just get rid of the decimal, or just go down to the lowest, the lower side integer. Okay. Power. So you just do the instead. So this is multiplication, right? But if you do double star, then it's power. So okay. And modulus. So modulus is basically getting the remainder after you do division. I think it's called long division. Okay, so let's do another thing. Does anyone know the answer to 11 mod 3? Oh shoot, no, let me change it to something else. Maybe 16 mod. Okay, I don't know. Let's just do that. 16 mod 9. Okay, so yes, the mod. So modulus. Yeah. So if you do 16 divided by 9, you get 1/9, and then you carry down the 7, and then the 7 is the remainder. Or we could do like 5 mod 2, 5 mod 2. You divide it. There's 2 2s that fit into a 5, and then you have a remainder of 1. Okay, so and then this would be a 1. Okay, so it's basically the remainder operator. Okay, so let's have here, we have a simple exercise. If you are given A and B, can you compute the sum of the quotient and remainder if you took A divided by B? So for example, if you did A equal 5 and B equals 3, the sum would be 3, because the quotient would be 1, because there's 1 3 that fits into a 5, and there's a 2 remainder. And then so you get a quotient of 1, remainder of 2. 1 plus 2 is 3. So feel free to, I'm going to give you guys like 10 seconds to think about it. And then I'm going to have you guys type in the chat. And preferably it'd be cool. So let's just say like 8. But like, let's just say you can take some arbitrary A and B. Yes, you put them into a formula or something. Okay, so feel free to type in the chat if you guys know the answer. Okay, so the answer is, so to get the quotient, we want to see how many fit in there without remainder. So what we do is, so A plus A mod B, okay? And so what this does is it gets the quotient, okay? And this gets the remainder. So this is how we do it. What? Sorry? Can you repeat that? Hello? Okay, never mind. I don't think that was a question. Well, if it was a question, feel free to like unmute yourself and say it, or just type it in the chat. Okay. Yeah, hopefully that makes sense. Does that make sense? Okay, so let's create a function, and so to create to find a function, you do def, and then let's do f just for now, and then what we could do is just return some like random value. And so whenever we call this f, we will get that value. And so let's just store f into x, and then let's see what we get. And we get 5 as we expected. Then we could take some like arguments. So let's just take an x. Let's take an argument a. It can be anything. It could be a arg. You can call it whatever. You can call it. It's basically a variable for the function. And so this would no longer work because we expect a here, but we're not passing anything. So let's just pass in a 3, and let's just have a plus that 5. So, and as you expect, we pass 3. This is 3 here, like going here. A would be 3, and 3 plus 8, 5 is 8. Okay. And so what happens if we want to so why would you use, well, technically so the main reason, a good reason to use function is to define a common set of reusable logic. So let's just create like let's just create a equation called equation, and then it takes the x, and then we return x squared plus 1, and this is parabola. Actually, let's just call this our yeah, just call it, it's just some equation. And so, and we want to compute this. Say we are, sometimes I use some Python to automate some of my homework calculations. I probably shouldn't do this, but I don't know if anyone else does this. Like if you're doing some chemistry, oh no, it was not actually chemistry, it was different. Yeah, I think it's statistics homework or something. So what I did was I just created, so if it's like repetitive, what I do, I just put, and like you have to do the same set of steps over and over, but with like different numbers. What I do is I just program the functions in Python, and then just pass the different numbers to the function, so I don't have to like do the process over. Like, well, all I have to do is just change some numbers, and then I can get the same process. And so let's have this equation. Okay, so let's compute the equation. Like 3, and then print equation 5. And you can see that we use this same code over and over again. So what we could do is we can not use this thing over and over, and just like 3, and just copy it 5. We get the same result, but what happens, like if you keep doing this, like what happens if you like mess up your copy paste, and then, or you like type something wrong or something, and then you just like mess it up, like you're doing your like math homework or something, and then you accidentally typed in a 3, and then like you're backspacing or whatever, and then you just type your random stuff, and then you accidentally put a 3 here. Well, then you might mess up, but if you just define it out here, then you can reuse it over and over. And so this is a pretty simple function. Sometimes you can have like a more complicated function, like well, let's not go over that right now, but simple functions, what you can do is define it in one line. You can see that, well, using something called a lambda. So you can see this takes up 2 lines, but what happens if we don't want to use 2 lines? So let's just comment this out. What a comment does are these pound symbols. You just put them in front, and it basically tells the program not to execute that code. So let's create a lambda equation equals, I meant equation equals lambda. So lambda is basically a function that you define in one line. Then we want to take an x, and then we want to return x squared plus 1. So let's see equation 3. Oops, I didn't mean to put the return. So whatever is after the colon or lambda is automatically returned. So you can just like pretend there's a return here. Like pretend this is there, but with a lambda, there's an implicit return there, and it automatically always returns whatever is after that. Let's just do the 3 and 5 just to see that we get the same thing. Oh, I didn't print it, whatever. Let's keep going. so you can see that these two functions are the same, but this is in one line. And sometimes it can be cleaner that way. Once you start programming more, you'll see why you use lambdas. And so let's have a control statement. Let's have a, okay, so if, else, if, and else, just treat it as English. So like if something, something, so let's just do x equals 5. So like if x is less than 5, you want to print x is less than 5. And then like else if x is greater than 5 and less, oops, and less than 20, print else, then you print else print. Okay, so actually let's obviously like the 5 is between it. What happens, but like what happens if you don't know ahead of time what x is? Like say it's some user input and they put their age, right? So age, you don't always know someone's age beforehand. They have to type it in, right? And so you might get some oops, just keep it as x. And so like say like there's some randomness in the variable, then you can just use this control loop to handle it. Okay. So, and sometimes we might like do something like something crazy equals 40 mod 7. Let's see what we get. Okay, whatever. Hopefully that makes sense. So yeah, just basically allows you to branch out your logic. So then let's go over some data structures. A list basically allows you to contain stuff in a loop. I mean, no, like say you have some like age, so temperatures, yeah, temperatures. And then we could do like 100, 101, 102, 99. Okay, so that's basically the list. Just contains a sequential collection of elements. And then we have a dictionary. So let's say we have like a name to age. Oh yeah, let me show you. Actually, let's just keep going. So a list you can index a list by so in programming, well, like most programming language, all indices start at 0. So you can see that. So we can see that there are 4 elements. To get the last element, we have to do 3. And if we did 4, we'd get an error because 4, so it's 0, 1, 2, 3, 4. There's nothing at the 4th index. So that gives us an error. So just something to keep in mind. And then you can also slice these things. So let's say we want to get, actually, let's not go over that today. It's a little complicated. Okay, so let's go over what a dictionary is. A dictionary is a collection of key value pairs where you can key the element to get the value. So let's just say like Bob and he's like 43, Amy and 12. Okay, so what we can do is print. So we can index name to age. Let's say we want to get the age of Bob. Skip, and then that's what dictionary is. A tuple is basically, let's say like xy point. A tuple is a fixed size list. So, oh yeah, I need to go over how to add stuff to lists. So we can create. So let's just do. To add something to the list, you can just do dot append and then like append for it. Before, but a tuple is basically a list, except the size is fixed. So once we put 2 elements in here, we can't add anything. So let's try appending something to the list. I mean, to this point XY. So we cannot add stuff. It is fixed, and we can't even change it. So with a list, you can set an element. So we can override the value at the 0th element by just setting it. So 0. So right now it's going to be 1, but we can override it and set it to like 3, and then let's just print this out. As you can, the element at the 0th element is overridden, and with tuples, you can't override stuff. So you can retrieve it as you do with the list, but you can't override its value. So this would be illegal. Okay. Let's go over for and while loops. So for loop, in Java it is like this. So for int I equals 0, I less than something, let's just n, and then I plus plus, and then you just do whatever. Okay, but in Python it's kind of different. There are no, oops, I in range n, and that's how you do it. So what the, let's just print I, and let's just set n equals 10, and this is how we print all the numbers from 0 to 9. So it kind of looks weird. The structure is kind of weird. So what this actually does, it's sort of like a for loop, but what it actually is it just basically iterates over the range data structure. And just think of a range as a list. It's a range object. We can convert it. Let's just cast it to a list to see what it, to get like some representation. So what it does is for I in range n, what it does is it sets I to the first element, and then I to the second element, I to the third element. So it's not really like a for loop where it's not, this I is getting incremented. It's just getting overridden by this new value here, one by one. Okay. And so what you can do with this type of for loop is you can also iterate over other, so this range is a type of data structure, but you can also iterate over a list. So let's just create a list equals 1, 2, 5. And you can see that we can, so we just changed a small part, and then we just get 1, 2, 5. Okay. And then a while loop. A while loop is pretty standard. So while and then condition. So condition. So what is a condition? A Boolean condition. And so if it's true, this loop executes, but if it's false, it doesn't execute. So let's just create, let's just iterate from 0 to 9 again. So while x is less than 10, print x plus equal 1. Okay. Okay, so what this is, oh shoot, I forgot to go over this. So let's go over back to the operations. So let's say x is 5. If we wanted to make it like whatever x is plus 1, what you do is you can do this equals x plus 1, and this will get a 6. But shorthand is just to put the plus in front, and you get the same thing. So let's do, let me just prove it. You can see we get the same result. Okay. And you can do this with other operations. Okay. Now let's go over dictionary. Okay, I promise we're gonna do something cool in just a second after this. Okay, so let's just do a equals 2, 4. 1, 2, 4. What we can do is we can let's just create a new list like A plus 1. A plus 1. Okay, plus 1. So a naive person might think like, can you just do this like A plus 1? Well, this won't work because you're trying to add a list and an integer, and like if you wanted to add an element into it, you do a dot append 1, right? So how do we do this? Well, we can do use something called list comprehension. So we can do, it's basically a loop. It's sort of like a loop. So for a element in A, we want to, so this is iterating. So this element is getting set one by one to this element. So element will start at 1, then it go to 2, then it go to 4. So then we want to keep something in this list. So you can see here that the brackets indicates this list, right? So we want to put something in here. So what do we want to do? We want to get every element in A plus 1. So our desired A plus 1 in this example would be 2, 3, 5. Okay. So what we can do is we can put whatever we want in here. So we put an element in here, but then we want to add 1 to it. Okay. So, oops. And let's see if this works. So A plus 1. And you can see that we get exactly 1. Okay. So can someone? Okay, I'm going to give you guys 20 seconds to figure out how we can. How do we get the squared elements of every element in there? So I'm going to give you guys like 20 seconds to like maybe type it out in Zoom, and then after like, actually let's just do 15 seconds. After 15 seconds, I'm going to have you guys post the answer in the chat. So actually, a squared. Oops, I meant shoot. Hope you guys. Okay, Parker got it right. Except we do need square brackets. Let's just do, I'm gonna be lazy and put E for E and A. And hopefully that makes sense. Let's do some leak code. Can you guys type in the chat if you guys, maybe I can make a poll. Actually, I don't know how to make a poll. I have to make some setting. Okay. For this, we're gonna add another data structure to solve this. Actually, no, we don't. Okay, so this is kind of tricky. Well, this is kind of tricky. Oh, I got it. Let me post this in the chat just so you guys can read it yourself too. And you guys can type it in here. So I'm gonna give you a hint. You're gonna have to use a dictionary. And let me just pull up the how to make a dictionary. Oh yeah, I forgot to go over how to test equal. Let me add this to this. Equality. Okay, so how do you test if two values are equal? So is 10 divided by 2 equal to like something is, what is it? Is it equal to 5? What we can do is use that equal operator, and that's how you create a Boolean. This is a Boolean, okay? So you're gonna do that. So I'm gonna give you guys like maybe like 3 minutes. 3 minutes to solve this.
Excuse me. I think you're still muted.
Oh shoots. Okay, so okay, no, sorry, I was muted. Okay, well, hopefully that gave you guys more time to think about it. Oh, thanks for telling me that. Okay, so so we want like num plus like some other num to be equal to target. Okay, so let's just if this num, and what we can do is rearrange this equation to get other num equals target minus num. And so you can see here, like if you subtract num on both sides. So we want to get this other num to be equal to, so we have to see if this number is already in our dictionary. So in this num to index dictionary. So we're just going to keep track of all the numbers. So if other num in num to index return num at, so we can do, oops. Turn so what this does is like if we've seen that other number that can get us, that we can add to this current number, then we can then we got the indices that we needed. Then we do index plus equal 1, because once we go to the next number, the index of that number goes up by 1. I forgot to put it. Shoot. I forgot to go. I forgot to go over dictionary or something. Did I go over that? Let me go over that real quick. So to add something to dictionary, you just like do it like you do for list, but yeah, maybe I shouldn't have gone over to this. Like, gosh, it's too much stuff. So what you can do, just put like the current number. I think that, yeah, I'm not gonna. There's more stuff. Let me go over that next. Oh wait, I forgot about that leak code question. I didn't teach you guys enough to do it, so I just forget about it. Okay, does anyone have any questions so far? I think I'm gonna end it soon. Feel free to ask me if you want to go over another topic again, like one of these topics that we never, or if you have like a question about the club, or if you have a question about me. So I'm just gonna open up to questions. Feel free to leave. That's gonna be it for today.
Well, thanks for doing this.
Hey, no problem.
Yeah, I
Thanks
guess
for
just one question. Do you know what the difference is between mathematical economics and quantitative finance versus CFRM?
Oh, that's a good question.
Because they seem very similar, but
Yeah, they always use like some weird term, like they always use some like flavor, like there's quantitative finance, there's mathematical finance, financial engineering, or something like computational finance. It's all pretty similar, I think. Yeah, it's sort of like synonyms, like it's whatever they feel like calling it.
That's so
But
funky.
yeah, there's like just a bunch of like different terms for the same thing. But I think like there might be slight differences. So because it's quantitative computational finance and so quantitative finance can be quite broad. There's like algorithmic trading, there's like the engineering part, like the infrastructure, like optimization infrastructure. There's the like there's a bunch of different methods, machine learning, stochastic processes, like linear algebra. There's just like so many areas in quantitative finance. So the name might have like a more like might have a more might reveal more about the program. So for example, if you did like a mathematical finance versus financial engineering might have more focus on programming side of algorithmic trading or quantitative finance or whatever. And while the mathematical finance might have more on proofs and maths and solving equations and stuff like that. And say like you mentioned quantitative economics, like that might have more stuff less related to direct trading, but it could have more related to trying to predict the interest rates or predict the next recession or GDP or whatever. So like it's quantitative finance is kind of a broad field. So the different terms just might like give like more insight onto which specific area that the program will focus on.
Oh, awesome. And then yeah, CFRM used to be known as financial engineering, right?
I'm not sure. Like it's pretty new program. Like Tim Lund, the department head, who's like the main person behind running everything. He used to, I think it's Columbia. I can't remember. It's not like some any like I can't remember some like East Coast school. He was like the head of like some financial engineer or some like some like program, and then he came here to UW. Like I think it was like 5 years ago or something, pretty recently, maybe like. And then he like started the CFRM program. I think the CFRM was the original name. I'm not sure, but yeah, it's a pretty new program at UW.
Oh, cool. Yeah, no, it looks really fun. So yeah.
Okay.
Okay, adios.
Okay, bye. I don't think there's. Are there any more questions? I don't think there are any questions. Okay, thanks for everyone. Okay, bye. I'm gonna leave.